Alright guys, so I'm going to go through our properties of logs for those of you that were not here when we went over this. We have 3 properties, so we need these in kind of injunction with what we were doing with rewriting. So remember your rewriting, how we go back and forth between log and exponential to log. We also need to know these 3 properties of logs as well in order to get to the point so we can solve. These 3 properties we're going to learn and the rewriting and writing that we've done before this all go in hand in how we start solving for logs, okay? Now, the 3 properties are pretty self-explanatory, I think. So going down, I'm going to give you guys a second. So if I were you, I would go ahead and pause this and put down what we have in the table so far. I did not go through all the values, and going forward you guys will see that I did not go through all of the table values. It's not as important as much as what's actually happening in the tables. And if you guys notice, we have, let me go ahead and erase this part, but we have 3 different rows. The first row just gives me 1 single log. The other 2 give me 2 logs that are either being multiplied together or they are being added together. So if you notice, what we are going to be getting towards is what we call expanding and condensing. So we have 1 log in the first column. We have 2 logs in both the other 2. So we're going to take those 2 logs and we're going to condense it down into 1. Now this only works when logs have the same base, and if you notice, all of them have the log base of 4. So thinking, if you look here, if we're condensing, that means we're getting smaller. So if I want to get to 12, the most likely thing with 6 and 12 right here would be to multiply them together. But that's not actually what we do with logs. Logs are a little bit of, sorry, close that out in case you saw that. Logs are a little bit of kind of opposite of what we would think. The one that actually goes together is right here, and we're not multiplying between that 6 and 2, we are actually adding, and they give us the same answers. All we did was plug those in our calculator to get those decimal values, and we rounded to the 3rd place. And if you notice, that happens that the first and the 3rd columns are all the same, okay? That's because multiplication, if we are multiplying arguments, that goes with addition, okay? That doesn't really look pretty. It goes with addition. Oh, there we go, a little bit better. So, going down, an example really is what will make a little more sense. So down here, and we're on page 9 if you guys didn't already figure it out. The pattern that we see here, we both have the same log base 3 of 8 and log base 3 of 9. So if I want to condense it to put it into 1 log base 3 of something, God, that's bad. Log base 3 of something. I got a new stylus, guys. I thought it would be a little bit better, but it's not proving to be better, but we'll see. So, we want to take these 2 logs and put them into 1 log and condense it. So in doing that, log base 3, in order to condense those 2 that were being added, we see up there, adding goes with multiplication. So it would actually multiply 8 times 9. So that condenses into the log base 3 of 8 times 9, which is 72. Okay? So now if you look down or scroll down or look at number 3, we were given log base 7 of 30, and we had to find 2 different ways, well, I found 2 different ways to expand it out. So we went from this 1 log out to 2. So really all I did was think of 2 numbers that multiply to give me 30, because we're adding, so if we are condensing that one to get 30, that means we had to multiply the 2 arguments. Now this is the reason I have 2, because there's many things that multiply to give you 30. 10 times 3, that would condense down to be a log base 7 of 30. 5 and 6. Those are the 2 different factors that we have to give us 30. You could have done log base 7 of 1 plus log base 7 of 30. Anything that if you're adding between them, you would multiply the arguments and give you 30. Okay? So mainly the pattern you've got to know is when we're condensing and expanding, or going from multiple logs to 1 log, multiplication goes with addition. Okay? Now, going to the next table, you probably can see a pattern going, but now we have subtraction and we're condensing to 1 log. So if we notice, we don't have multiplication anymore, we actually have division. So division and subtraction go together. We did one of the rows. You guys could pause and look at the pattern from each of them, but if we are going from 2 logs and condensing to the other, 10 divided by 2 would give me this 5. Instead of actually dividing the logs, we're going to subtract between them. So division goes with subtraction. Alright? Going down, again, I wasn't going to be repetitive and do this whole thing, but if you guys would like to, you can. So now here on number 6, we noticed we had 2 logs, and I wanted to condense it into 1. So we have subtraction between. We just saw subtraction and division go together, so unlike what we did last time, if this was an addition sign, I would multiply the 2. But now we have subtraction, so I'm going to divide the 2. So 20 divided by 5 would give me log base 2 of 4. So this guy right here actually expands out to be log base 2 of 20 minus log base 2 of 5. So if I plug this into my calculator and this guy, they should be equal. And now here, just like we did before, we are going to be representing it in a different way, but we're going to use division, okay? So if I'm dividing, I need to think of 2 numbers that divided to give me 8. I thought of log base 3 of 16 minus log base 3 of 2. Because if I condense this, I would divide 16 and 2 and give me 8. You could have also done log base 3 of, heck, I don't know, 32 minus log base 3 of 4. 32 divided by 4 would give me 8, okay? The key is that they always have the same base. And these different rules can only happen when you have the same base, okay? So division goes with subtraction. And last pattern. Now, I've already kind of rewritten this, so I would pause and kind of write down this table. It looks a little crazy right now, but it'll make a little more sense. The last and final rule is if we have a leading coefficient at the front. This is what I call the exponent rule. I don't know if that's what it actually is called, but that's what I call it. If we have a number up front, we go ahead and make it the exponent of our argument. So if you guys notice, between this first one and this second one, this, if I make 4 the exponent, it's 2 to the 4th power. Now 2 to the 4th power is 16, that's why the both of these are the same. Here, 25. If 2 becomes his exponent, 5 squared becomes 25. That's why these are the same. All of these, the main thing you have to know is if you have a number in the front, it becomes the exponent when we are condensing, okay? So that is our last and final rule. These make more sense when you guys go in and use them. So let's see. Number 11, log base 5 of 36. I wanted to represent it in a different way, so I rewrote 36 as 6 squared. So if we have an exponent, that means if I expand it back out, that 2 would go back in the front. Or if I expanded it or condensed it, I would put 2 as the exponent, go back and forth. Mainly what you got to know is if there's a number in front, it becomes the exponent of the argument, okay? This stuff we didn't go too much in detail of, but down here at the bottom is our 3 different laws of logarithms, okay? Knowing these is key. All you got to know is that addition, if you're condensing, so we have 2 logs here, we condense, we multiply their arguments. 2 logs here, if we condense and you're subtracting between, you divide their arguments. If there is a number out front of your log, it becomes the exponent of our argument, okay? So, I've gone ahead and done some examples. I'm not going to scroll all of them. Your homework was to do the odds. So I want you to try some of these. If you look at the first 6 of them, I did some kind of examples here, okay? I want you to pause it, write these down, kind of look over what we did, and go through and do the rest of the odds, okay? Now, at the bottom, number 13, you do not have to worry about doing this. You can try it if you would like. But on this page, we are, if you notice, it's condensing. So I'm going to 1 log. So all of these, when you're condensing, should have 1 answer, okay? Right here I had 1 answer. It should all be 1 answer, okay? And on the next page, here you're expanding. So you're taking 1 log and making it to mini logs. Except for number 17, it's a little different. You have your exponent rule, so all you're doing with that 4 is really putting him as the number in front of 4, okay? So I want you, once you finish this video, work through the odds. This will be your homework. And then next class we will be using what we know about rewriting, expanding and condensing, and these log properties that you guys just learned. And we're going to start solving logs, okay? We need all of those skills, and we need to have a good baseline of those skills in order to start solving. All right? So go ahead, do your homework. I will check it once you are finished, and then we're going to be moving on. Thanks, guys.